Hi, I'm Louis Mangan, and I created this little proof to illustrate a couple methods on how to use entropy as a timepiece in order to determine the age of the continents. Even before I received the Bachelors of Science or before I took thermodynamics in college, it was self-evident to most observers that the continents are still fitting together like puzzle pieces, even after supposedly receiving hundreds of millions of years of erosion and its associated sea level rise. Then a few years back, I discerned a few common sense ways of using entropy as a timepiece to discern the true age of the continents. First, a little insight into the second law of thermodynamics, entropy. By definition, entropy is a thermodynamic quantity representing the unavailability of a system's thermal energy for conversion into mechanical work. Now, that statement is often interpreted as the degree of disorder or degradation in the system, or in layman's term, the gradual decline from order into disorder. To further help clarify, let's look at entropy's synonyms: deterioration, crumbling, degradation, decay, decomposition, breaking down. Now, what are these self-evident ways that we use entropy as a tool or a clock to see the age of continents? Forensic scientists use the rate of decomposition, entropy, of a dead person to determine a person's time of death. You can use entropy's decomposition rates to determine the age of vehicles, buildings, most everything. A great geological example of entropy being employed as a timepiece that resembles what we will employ is the use of entropy to age Niagara Falls. Niagara Falls erodes away at about 1.3 meters a year. So now we can see where Niagara Falls was 9,000 years ago and where it will be 1,000 years in the future. So to create this entropy timepiece needed to age the continents, we need a distance change per time like we did with Niagara Falls. So to create this entropy timepiece with the continents, we need a distance change per time like we did with Niagara Falls. So what distance rate per time can we use to determine the age of the continents? Like the sand filling an hourglass, the continents erode enough into the oceans over 1,000 years to cause a displacement or rise of the ocean levels by 1.7 meters. At least that's how it's been for the past 5,000 years. I looked at some studies pinpointing the ocean rise over time for the past 14,000 years. Specifically, Balsillie and Donoghue, as well as the ANUs, these two groups show that the oceans rose about 8.5 meters during the last 5,000 years, and about 104.5 meters the 9 millennia before that. That's equivalent to about 110 to 113 meters rise in 14,000 years. So, 110 to 113 meter rise in 14,000 years. If you were to project that rise in ocean levels using our present continents, you would discover they could no longer tell they once fit, which on the surface would lead us to believe that the continents are less than 14,000 years old. So, using topographical maps and displacing the continent's lower elevations with water rise, we can see what happens to the appearance of the continents and get a distance over time on each continent to estimate the age of the continents, time that the ocean has claimed from the continents, from the present to the 110 meters ocean level rise that occurred during the past 14,000 years. this ocean rise distance over time on the continents gives us a baseline of distance lost over time for each continent. This missing land can now be seen as the time it took for the ocean to cover the distance of land between present Madagascar and Africa to make a perfect fit, and South America and Africa to make a perfect fit. This distance claimed by rate time is their age. Now, when we put the pieces together, we can mark points of measurement that correspond between both land masses. One landmass will have a different rate, distance versus time than the other, as the oceans rose to cover land due to differences in elevation. Here I identified points A through H to take measurements of the land covered over time for Madagascar and Africa, and the distance of the present gap between them to make a perfect fit. To help our accuracy increase, we must do this for more than 7 points between the continents. Mark the distances changed over time for ocean level rise on point A, Madagascar, and corresponding point A, Africa, and the distance lost over time for the line distance for point A. Total the distances of the land consumed during the 110-meter ocean rise over the simulated past 14,000 years. On the lands of Madagascar and Africa, along the A line, divide the Africa distance consumed by the ocean by 14 to give you the distance covered per time per 1,000 years on the African side. Now do the same for Madagascar. Now determine the percent of the 2-foot distance that belongs to Africa, and determine the percent or ratio of the 2-foot distance that belongs to Madagascar along the point line. Now, using Africa's ratio of the percent distance to fit, determine its portion of kilometers of the 2-foot to fit perfect distance, and then do the same for Madagascar. Now we take the African fit distance and divide by its previously calculated distance traveled per 1,000 years. Then do the same for Madagascar. This gives Africa's and Madagascar's lost fit times in thousands of years. Now add Africa's fit time to Madagascar's fit time. Then repeat the same process for each point along the African and Madagascar fit zones. This gives Africa's and Madagascar's lost fit times in thousands of years. Now add Africa's fit time to Madagascar's fit time. Then repeat this same process for each point. When all the ages are completed for each point, then average all the determined ages for those points together. Now repeat this same process and determine the distance per ocean rise over time for the age of South America and Africa. This gives us an estimated age of the continents according to the entropy that occurred over time, or the last 14,000 years. So Madagascar is estimated at being 23,000 years old, and Africa and South America is estimated at being 14,000 years old. And if you average the two, then the continents, using entropy as a timepiece like we did for Niagara Falls, then the continents are 19,000 years old. Ocean level rise rates was the first entropy clock I employed to determine the age of the continents. The second method I employed was to use the recorded coastal erosion reduction rates that occurred over time during the past century in the Americas, Europe, South America, Africa, Madagascar. I discovered that the pounding sand and waves on the coast of our continents is very abrasive and has occurred at a fairly constant entropy rate during the past 5,000 years. Pre the Ice Age melt and pre the Greenland ice melt. If you are performing this proof, you'll discover that the coastal hard rock erodes at 0.3 meters a year, soft rock at 0.7 meters a year, and sand and dirt erodes at about 1.5 meters a year, or 150 kilometers in 100,000 years. 150 kilometers in 100,000 years. So when you lay out recorded coastal reduction rates around the continent maps, you can see land loss versus time. And I did just this in 100,000 year increments. Along the coasts of Africa and South America and Madagascar, then cutting out the newly reduced continents over their 100,000 year increments of time, and from those perform coastal reduction again and again for another 100,000, meaning that the continents retaining enough shape to still fit after 200,000 years is impossible. So dating using this method is relatively the same as using ocean level rise, in that you'll take the measurements over several points and determine the age at several points and average them together to get a common age for the continents, or an average age for the continents. Using this coastal reduction method, not accounting for the sudden 104 meter ice age rise over 9,000 years, Madagascar is 147,000 years old. And the age of Africa and South America is 107,000 years old. Averaging the two together makes the average age of the continents 127,000 years old. The difference between the two entropy age determinations is that the coastal reduction takes into account the different erosion rates along the shores, but does not account for the additional 104 meter ocean level rise that occurred due to the Ice Age melt. Geologists state Madagascar is 300 million years old, while keeping it still fitting African shape over time. Yet, even at last century's coastal erosion rates, Madagascar will only take about 220,000 years to reduce to 2 tiny islands, and at present reduction rates, it will be nothing in the same amount of time. We could have measured the age of the continents a different way using entropy, by measuring the depth of sediment from the eroding continents at the bottom of the ocean. If the continents had moved apart at 2.5 centimeters a year, the ocean would have filled with sediment, not leaving any kind of trench. At the bottom of the oceans are signs of gigantic magma solidified P waves, power waves. Within the Mid-Atlantic ridge, we could have fit South America and Africa along these P waves that are still in the ocean. This would not even be possible if the sediment that had eroded from the continents had covered up this evidence over time. This Mid-Atlantic ridge is a trench in the Atlantic Ocean about 7 kilometers deep. If the continents had moved away at 2.5 centimeters a year, the erosion from the continents would have left little, if any, evidence of a trench, and no place on a magma solidified wave showing the origin of the separation, and the continents would no longer fit due to the entropy clock. Some have told me that the land on the continents just replaces itself. So the continents always retain their same shape. That's why they still fit after hundreds of millions of years. We saw from the continent erosion projections and ocean rise over time projections the appearance of the continents changing over time, with the last pieces of the remaining continents being at the lifted and collision points or subjection points and at the ring of fire. There isn't some magic anti-entropy genie digging up the eroded contents from the bottom of the oceans and placing the sand back as the original rock. In the original still fitting continents for hundreds of millions of years. So what could have caused this solidified power wave where the continents obviously split apart from? Yes, you're probably thinking the same thing. An asteroid strike, with its subsequent power waves and surface waves splitting and pushing the continents to their relative positions that they're in today. Entropy is perhaps the greatest law of science in terms of usefulness and in terms to age. I hope you take the time to perform this proof yourself using entropy as your time clock. I hope you take the time to investigate erosion rates over the past 5,000 years and the rise of the ocean over the past 14,000 years. And the constant rise of the oceans and its change over time on the face of the continents. Entropy changes everything. This movie changes everything.